Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Peas and Love. Not peace and love, Peas and Love. And it's by Chris Napolitano, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, we can get a column here, or designated 9-cell region, which in this case is a box. We also have split P lines, where digits on a split P line between the two circled cells, and excluding the circles themselves, must sum to a 2-digit number formed by the digits in the circles in either order. And it's a concatenation of the digits in the circles. So, for example, these digits must add up to one of these digits as a tens digit and one of these digits as a ones digit. So you could have something like, I don't know, let's try 25. And these 5 digits must add up to 25. So you could have something like, I don't know, 6, 7, 3. Does this work? I don't know. 4, and so this is 10, 20. Oh, we need a 5 there. That wouldn't work. 8. So 10, 24, and this would be 1. Actually, this works pretty well because this would be 4 either way because it's 1 to 2 ratio and this adds up to 10. Anyways, that's an example of how split P's work because these digits add up to 25 and the digits in the circles around the split P line can be concatenated into 25. It could have been 52 also, but obviously this one didn't add up to that. We also have global entropy, where every 2x2 area of cells in the grid must contain at least one digit from each of the following 3 groups. We have low, which is 1, 2, or 3, middle, which is 4, 5, or 6, and high, which is 7, 8, or 9. So, in any 2x2 area in the grid, you have to have at least one digit from the low set, which is 1, 2, 3, one digit from the middle set, 4, 5, or 6, and one digit from the high set, which is 7, 8, or 9. And then you have a final 4th one, which could be any of the other ones, right? Any of the sets. But you have to have at least one each of those 3 distinct sets. We also have counting circles, where digits in circles indicate how many circles contain that digits. Digits connected by a white dot are consecutive. Oh, sorry, that was the next one. But digits in circles, so if you had 3 here, that would mean there are 3 3s in the circles, right? Because that says there are 3s. There are 3 other 3s in the circles. There are 3 3s total in circles. And that's an example of how counting numbers. So it could be something like 3 here, 3 here, and 3 here. And that would be valid. We have digits connected by a white dot are consecutive, and digits connected by a black dot are in a 1 to 2 ratio. So like the example I gave previously, where this was 2 and I guess this would actually have to be 5, and that's what yeah, actually this could still work. 5 and 2, and this is 4. No, I think this was 8, 7, 6, and 3. Because this, okay, so yeah, using these as examples, the white dots, so these are called white Kropke dots, are consecutive. So if this were 6, this could be 5 or 7, because these digits have to be consecutive, and this fulfills that. If this is 8, that would be in a 1 to 2 ratio with only 4, and that fulfills that. So that satisfies there. We also have digits separated by an x summed to 10, and these 2 digits add up to 10. So that actually works too. I don't think this is actually the solution, though. That's funny that this actually worked out pretty well, right? This is 2. Yeah. Anyways, there's that. We also have clones, where 2 gray regions contain the same digits in the same arrangement without rotation or reflection. So basically, this digit must equal that digit, this digit must equal that digit, this digit equals that digit, and this digit equals that digit. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so this is in a 1-to-2 ratio, and it must add up to a 2-digit number. The only 1-to-2 ratio that works on is 4 and 8, because 3 and 6 adds up to 9, so anything less than that is not going to work. And this must be 4 and 8. Well, since this is 4 and 8 adding up to 12, one of these is a 1, the other one is a 2. How many counting circles do we have? We have 1, 2, 3, 4, 5, 6. So the total number of digits in the counting circles must add up to 6 exactly. We know we have a 1, we know we have a 2. So we have 1, 1, and we have 2 2s. That means the other digits must be 3s. So the 1s are already accounted for. This must be a 2-3 pair, because those are the only digits remaining in circles, and therefore this is a 2-3 pair also. Actually, it cannot be. This has to be a 3 and a 3. So this adds up to 33. Because we have 2 2s accounted for, one being here, one being here. Therefore, this must be 33. This adds up to 23 here, so this must be 6, 8, and 9. It can't be 32, because 3 digits can never add up to anything greater than 24. So this is guaranteed to be 6, 8, and 9. This becomes a 4-8 pair. This has to be 1 or 2. These add up to 33. Where is the 3 in box 6? It has to be one of these digits. So either this is a 3, which makes this not 3 or 7, obviously. Or this. So what digits are here is kind of a good question. It could be 1, 2, 3, 4, 6, or 8. 3 can't be here, so this can't be 6. Therefore, to add up to 10, 1 and 9 work. 2 and 8 could be there. 3 and 7 could be there. This can't be 7, though, so this can never be 3. Or it's 4 and 6. Okay. This 3 is in a 1-to-2 ratio with only 6. So this is 6. This cannot be 4 and 6. This can't be 3 and 6 either as a 1-2 pair. So this can't be 4 and 6. This can't be 7 anymore. This is 2 and 8 with 1 or 9. Whereas the 3 in box 6, it must be here. So since this is 3, this can't be 3. This is 2. That's 3. If this can never be 8, because if this were 8, that would force us to be 4, and therefore this would have to be 6 to add up to 10, but we already have a 6 in the box. Actually, this has to be, to add up to 10, this is 1, 9, or 2, 8, because we can't have 3, 7, or 4, 6. So this is also 1, 2, 8, or 9. We have a 1, 2, 8, 9 quadruplet in box 6, which eliminates 1, 2, 8, 9 in the rest of the box. This can't be 1, 2, or 8, so this is 4. That means this is a 5, 9 pair. Well, 5 is not consecutive with any of these digits, so this has to be 9, which makes this 5. That makes this an 8, which makes this a 2 to be in... Wait, that doesn't work. This can't be... Not 5 or 9. 5 or 7. Okay, 5 again cannot be consecutive with this, so this does have to be 7. This is 5. That makes this, yeah, this 8 and this 2. And that satisfies this. This becomes a 1, 9 pair here. So this is 5, 8, 7, 4. What does that add up to? 5, 7, and 8 adds up to 20. Right? 15 plus 5 is 24. That means this is a 9 to add up to 33. 24 plus 9 is 33. Okay. This digit cannot be 6, 8, or 9. It can't be 1 or 2 because this is separate, different 1 or 2s. So it cannot be 6, 8, 9, can't be 1, 2, can't be 3, 4, or 8. So it's 5 or 7 here. Right? Can't be either 1 or 2 because these are different 1 or 2s. Can't be 3, can't be 4 because of the 4, 8 pair in the box. Could be 5. Can't be 6, 8, or 9 because of a 6, 8, 9 triplet in the column. Okay. So now we need to start marking low, middles, and highs. So this is middle. This is high. This is high. This is middle. We have low here. Low here. This is high. This is low. This is low. This is low. This is low. This is low, and this is low. Okay. So, we are missing a low from this 2x2 area, so this is 1, and this must be 9. So this is low, this is high. This is low also. We have 2 lows here, so it must be we are missing a high in this 2x2 area. So this is 7, 8, or 9, and must be high. This is middle or high. It can't be 8 here. So this has to be, it cannot be an 8, 9 pair. So this must be 7, and that must actually be with a 6. So this can't be high. Because it can't be with 8, because those wouldn't be consecutive. This can't be 6 then, which makes this a high. This could be anything, so we don't know. These digits are consecutive. This cannot be... What digits can this be? I guess this could be 7 and that could be 6. That's possible. This is only a middle if it's 6. Say that wasn't a 6. So 6 has to be one of these two digits here. This one of these digits has to be from a middle set. If this is not 6, it can't be 3, it can't be 7, can't be 4 or 5. So this would have to be 1, 2, or 8. And that's not consecutive with a middle digit. And 1, 2, or 8 would not be a middle digit. Therefore, this has to be a 6 here. Because there's no other possibility. And this could be consecutive with 5 or 7. That's fine. So again, if this is not 6, it can't be 3, 4, 5, 7, or 9. So it would be 1, 2, or 8, which is not a middle digit in this 2x2 area. 1, 2, or 8 cannot be next consecutive with a middle digit, so this would not be a middle digit, and this 2x2 area would not have a middle digit, which is contradicted. So this must be a 6. That's the reason why we know that. Remaining digits in column 8 are 1, 2, and 8. Remaining digits in column 7 are 1, 4, 5, and 9. Okay. And 9 cannot be any of these. We have a 1, 4, 5 triplet, actually, in box 9 and column 7. That eliminates 1, 4, 5 in the rest of the column and the box. This can't be 1, 4, 5, so this is 9 and a high. This can't be 1 because of the 1, 4, 5 triplet. This can't be 5, so this is 7, which is high. These cannot be high, so this digit must be a high here for this 2x2 area to work. Therefore, this is an 8, which makes this a 2 and a low. These can't be 8. These are both 1, 2 pair, which means those are both low. We need a high in this 2x2 area and this 2x2 area, so this must be high here, which makes this 8. This has to be a 4, 5 pair. and are the middles. We need, okay, so this has a low, but we need a low in this 2x2 area. Hold up. Okay, yeah. We need a high here. We need a high here. If there were a high here, that would not be a high here, so this would be two mediums, which is not allowed. This could be anything. We need a low in this 2x2 area, so one of these is a 1, which means this can't be 1. This is middle. Okay, this 8 eliminates 8 here, so this is a 9, which means neither of these can be 9. Where is the 9 in row? Okay, this 8 eliminates 8 here, so this is 4, this is 8, which forces this to be 4 and 8. So this is a middle, and this is a high. That 8 eliminates 8 here, so this is 6, and this is 8. That 6 must be middle. This 8 is high. This is a low, obviously. Where is the 9 in row 3? Can't be here because of the 9 in the box. Can't be here because of the 9 in the box. Can't be here because of the clone this. So this must be a 9. And this is high. This could be any of the sets. It's fine. We have two middles here and a high, which means this has to be low. So this is the 1. This is middle then. This can't be 1. This 1 eliminates 1 here, so this is a 2. That forces this to be 1 to add it to 12. This is then a 2. This is middle, and this is high. So this could be either 5 or 7 still. This 4, though, eliminates 4 here, so this is 5. This is 4. 5 eliminates 5 here, so this is 7, which makes that a 7. So this is a high, and this is a high. And now we just have to figure out by sort of normal Sudoku where things could be. Or not normal Sudoku, 2x2 global entropy of where things could be. 1, 4, 5, and normal Sudoku, but, yeah. This is 1, 4, 5, 1, 4, 5, so that's fine. Either one. Row 2 has to be 1, 2, or 9. And this can't be 9. So this is, no, 1, 2, or 5. This can't be 1 or 2, so this must be 5 then. This is green, this is low, and a 1 or 2. And this cannot be 1 because one of these two digits in row 3 has to be a 1. So this must be 2, which makes this 1, which makes that 2. This is low. We have 3 digits here, so that's fine. We have 3 different sets here. That's fine. Remaining digits in box 1 are 1, 3, and 6. Obviously, this can't be 1. Remaining digits in row 4 are what? 1, 4, 6, and 7. This can't be 1 because of the 1 in the column. This can't be 7. This can't be 4. Okay. Rest of row 7 is 2, 6, and 8. This can't be 2, so this it can't be 8. So this is a 6, which makes that middle. This becomes a 2, 8 pair. Cannot be 2 here because of the 2 in the column. So this is 8. This is 2. That means this is high. This is low. By global entropy, we need a high digit here, so this is a 9. This could be anything. We need a middle digit here and a middle digit here. If this were a middle digit, we would no longer have enough middle digits here, and therefore this 2x2 area wouldn't have a middle digit. So this must be a middle digit here, and it is the 5. That leaves this as a 1, 3 pair, so both of these are low. That leaves in row 8, the remaining digits are 3, 4, and 5. The remaining digits in row 9 are 6, 7, and 9. So this can't be 9 here because of the 9 in the column. This can't be 5. This can't be 7. This can't be 4. These are all filled out. That's fine. We have a 3, 4, 6, 7 quadruple in column 3, which eliminates 3, 4, 6, and 7 in the rest of the column. That leaves 2 and 8. And this can't be 8 because of the 8 in the column, or in the row, so this is 2. That makes this an 8. So this is low, this is high. This can no longer be a 6 because of the 6 in the column. That means one of these 3 is a 6. We're not sure which. This can't be 4 because of the 4 in the column. Remaining digits in row 1. It can't. This is a 1, 3, 6 triplet. That makes this 4, 5, 4, and 7, 8. This cannot be 5, 7, or 8, so this is 4, which means this is middle. That means this also can't be 4. This becomes a 1, 5, 1, 5 pair, which eliminates 1 and 5 in the rest of the box and the rest of the row. So this can't be 5 here. This is 4, which makes this 5. This becomes a 7, 8 pair. So both of these are high. This could be anything then. This 8 eliminates 8 here, so this is 7. This is 8. This 3 eliminates 3 here, so this is 1 and 3. 1 eliminates 1 here, so it's 5 and 1. This is therefore middle. This is low. So this cannot be 1. This is 4 or 7. It requires a middle digit here for this 2x2 area. Therefore, it's a 4. Remaining digits in column 6 are, what, 5 and 7. 7 cannot be here, so this is 5. This is 7. This is then a middle, and this is a high, which satisfies this 2x2 area. We need a low for this 2x2 area, so this is low. It cannot, it's 1 or 3. And this is also 1 or 3, but it can't be 1 because of the 1 in the row. So this is 3, this is 1, this is a low, and this is a low. In this 2x2 area, we need a middle. So this is 6. That leaves this as a 9 and is a high. This 2x2 area has a low and a middle. We need a high. So that makes this a 7, which makes this a 6, that a 9, that a 7. This 6 eliminates 6 here, so it's 3. That's 4. That means this can't be 4 here. These can't be 3. This is low. This is middle. These are high. This is also middle. So we need a low here in this 2x2 area. So this is low and a 3. This is must be 5 and a middle. This can't be 7 and this can't be 4. We need a middle in this 2x2 area. So this is middle here, which makes this 6. This is 1. That means this is low. This can't be 1, so this is 6 and a middle. This is 1 and a low. We need a middle digit here in this 2x2, so this is a middle and it's a 5, which forces this to be 3 and a low. That forces this to be high and a 9, and this is middle and a 4. So this is 9 and this is 4. And that's how you solve it. Yeah, pretty nice little puzzle here. Fairly straightforward though, but like with the global entropy, if you can fill out the rest of the puzzle, right? Fairly easily. Nice little puzzle though. I enjoyed it, and I hope you enjoyed this solve. And I'll see you next time on Frank Puzzles. Take care.